We're going to start here with some very basic examples of exponential equations. In general, what we do here is basically just abuse the fact that exponentials are one-to-one and throw some logs at them. But sometimes you get really nice things to work with where we just have the same base to begin with. And we have the same base to begin with. We actually don't need to do very much work because all we really need to do is think about what happens in those exponents to make those two things equal, and that gets us to the answer we want. So we'll take a couple of quick examples here to check with that before moving on to the more advanced things. So for this, we want to solve the exponential equations 4 raised to the power 2x minus 6 equals 256, and 27 to the x minus 1 equals 81 to the x plus 1. So that first case, what we want to do there is think a little bit subtly, think a little bit carefully, and recognize that when we have the 256, that's actually 4 to the 4th power. So, for our first example there, we have that 4 raised to the power 2x minus 6 equals 256 is the same as 4 raised to the power 2x minus 6 is equal to 4 raised to the 4th power. And since we have the same base, we can just focus on what happens with those exponents, and this turns into 2x minus 6 equals 4. And from here, you add over 6, divide out 2, get x is equal to 5. So our solution set would just be 5. A lot of these are going to turn into somewhat nice linear things, maybe quadratics. Then for our second, we're going to do kind of the same thing, except it's a little bit more clever there, that we have 27 to the x minus 1 is equal to 81 to the x plus 1, and we're going to recognize that 27 is 3 cubed to the x minus 1, and 81 is 3 to the 4th to the x plus 1. So we can pull these apart, recognize that we have base 3, and use the product rule for exponents there to get that this will just turn into 3 times x, not lambda, minus 1 equals 4 times x plus 1, or 3x minus 3 equals 4x plus 4. Add over 3, subtract over 4, and we will get x is equal to negative 7 as our solution set. But expecting things like this, it's not really fair, it's not really reasonable, it's honestly a little bit too easy. So we're going to look at some cases next where we have exponential things that take a little bit more thought.